All right, today we're diving into a huge shift in how we discover new materials. We're basically taking the entire research and development lab and moving it into the cloud. We're going to look at a platform called MatXra, which is, well, it's completely changing the game for the scientists who are building our future.
So, if you're a researcher, this question probably hits pretty close to home, right? Designing new materials, whether it's for a better battery or a stronger alloy, has always been this long, expensive, and let's be honest, often frustrating process. We're talking years of work, not months. But what if you could just break that cycle?
Let's talk about what that bottleneck actually looks like in the real world. You've got critical data just scattered all over the place, trapped in different systems. Your teams are working in silos, which absolutely kills collaboration. Access to a real supercomputer? Forget about it for most people. And the simulation software itself can be so complicated, it just becomes another wall to climb. These are the very things that grind innovation to a halt.
And this is exactly the problem MatXra was built to solve. This isn't just another tool. Think of it as a complete ecosystem, designed from the ground up to shatter those bottlenecks. The idea is so simple, but so powerful. Put everything you need, designing structures, running heavy-duty simulations, even building AI models, all into one place online, where everyone can work together.
It really boils down to three big ideas. First, you've got to accelerate the work. Everything you do lives in one searchable place, so you're not wasting time just hunting down data. Second, you have to boost productivity. The interface is clean and easy to use, so your team can actually get work done instead of fighting with the software. And third, you need to scale up collaboration. It's built to connect you not just with your immediate team, but with researchers all over the world.
So let's peek under the hood for a second. What's powering all this? You get secure, on-demand, high-performance computing right from the cloud. You can literally design new materials in your web browser. It plugs directly into the big industry-standard simulation engines like Quantum Espresso and VASP. And for the power users, you get full API access and the infrastructure you need to build some really serious machine learning models.
Okay, that all sounds great in theory, right? But what happens when the rubber meets the road? What does this actually look like when thousands of researchers from around the world start using it? Well, the numbers tell a pretty incredible story.
First up, we are not talking about a handful of small experiments here. We're looking at nearly 37,000 unique simulation workflows. Each one of those represents a complex research question that someone set out to answer. That's a lot of science happening. And those workflows have been used to build up this massive digital library. Think about this. Over 64,000 different materials are now stored inside this ecosystem. That creates this incredibly valuable searchable database for the entire research community. And just look at the raw computational muscle here. Over 73,000 separate calculations have been run. I mean, that's a level of processing power that is just completely out of reach for most individual labs or even companies. The scale is just wow.
Now, numbers tell one part of the story, but the real proof, that comes from the scientists themselves, the people using this platform to really push the boundaries in their fields. So let's hear what they have to say.
First, we have Dr. Sergey Barabash from Intermolecular, which was acquired by Merck. He hits on that first pillar we talked about, acceleration. He says MatXra allowed them to significantly accelerate their R&D efforts. That's a direct confirmation that this is helping to speed up the actual process of discovery.
Next up, Dr. Kazuki Mori from Ito Chu Techno Solutions points out two things: speed and organization. He notes that the platform improves the speed and accuracy of their modeling, and, this is huge, it helps organize the resulting data. That directly tackles that problem of fragmented information we mentioned at the start.
And finally, let's hear from the academic world. Dr. Jun Koyanagi from the Tokyo University of Science highlights what might be the biggest game changer of all: access. He says that with MatXra, his team has top-tier computational resources in a very cost-efficient manner. This is democratizing science, giving powerful tools to universities and research groups that could never afford them before. And this isn't just theoretical. The platform is already powering real-world, honest-to-goodness breakthroughs. Researchers are using AI to find new catalysts. They're designing the next generation of solid-state batteries. They're creating advanced lightweight alloys for new planes and cars. I mean, this is the stuff that will literally shape our future. So you might be thinking, okay, this sounds amazing. How do I get my team started? Well, let's walk through the options because it's actually pretty simple.
The whole thing is designed to be really accessible. You can actually start with a free plan, which is perfect if you're just one person wanting to explore a project. When you need a bit more firepower, you can move up to the Pro plan. And for big teams doing large-scale work, the Enterprise plan has you covered for multiple projects and full-on collaboration.
The most important takeaway here is that there's really no barrier to entry. You can start for free, play around in the ecosystem, run some simulations, and just see if it's right for you. You only need to scale up when your research is ready to scale with you. And that really brings us to the final thought. When you have tools like this that just tear down all the old barriers, the cost, the access, the complexity, what are you left with? The only limit is the research question itself. So the question isn't really what the platform can do. It's what breakthrough will you simulate next?